Good day, we are the Group 3 from BS Architecture 2D, and today we are going to talk about Building Construction 3, Heavy Reinforced Concrete, Pre-Stressed Concrete and Steel Construction. I am Theophany Balsi Arcacho. I will be talking about roof decks. Reinforced concrete roof slabs, or roof decks, are formed and site cast in the same manner as concrete floor systems. Roof decks are normally covered with a type of membrane roofing for insulation and waterproofing. The first figure shows an upturned edge beam can form a parapet wall. A metal reglet may cast into the parapet to receive cap flashing. A parapet is like a wall on the edge of the roof deck to keep people from falling off the roof. The second figure, the slab can be cantilevered beyond its perimeter supports to form an overhang. A cantilever parapet usually uses glass or transparent plastic to serve as a parapet for the roof. The last figure, an edge or spandrel beam can support a non-bearing curtain wall. Metal anchors may be cast into spandrel beams to secure the curtain wall panels. It is a horizontal structure made of steel or concrete constructed along the perimeter of the building to take the wall loads or some of the roof loads coming over it. So these are a few material specifications of a roof deck. We can see here stone or precast concrete coping, rubbed or embossed through wall, flashing and cap receiver. Cap flashing 4-inch 25 lap minimum. Base flashing should extend 8 inches to 12 inches, 205 to 305 above the highest anticipated waterline. Anchor plate with compression bars, continuous slit, formed metal coping, anchor gutter bar, anchor bolts, extruded aluminum coping. Gravel stump must be hydrogen roofing gravel. Can dam, base flashing over can dam. Next, walls and structural walls. So there are 5 types of walls. Number 1, bearing wall, a wall on which either floor or roof construction rests. So basically, a bearing wall, or also called load-bearing wall, is a wall that is an active structural element of a building, which holds the weight of the elements above it by conducting its weight to a foundation structure below it. A quick information, load-bearing walls are one of the earliest forms of construction. Next are curtain walls, the enclosing wall of an iron or steel framework, or the non-bearing portion of an enclosing wall between piers. So a curtain wall is defined as a thin, usually aluminum framed wall containing infills of glass, metal panels, or thin stone. The framing is attached to the building of the structure and does not carry the floor or roof loads of the building. Third is foundation wall, that portion of an enclosing wall below the first tier of joists. Foundation wall is the masonry or concrete walls below the ground level. These walls serve as the main support for a structure of your home. This means that they are extremely important to the overall structure of your home. Foundation walls also form the envelope of a usable basement. Fourth is the retaining wall, a subsurface wall built to resist the lateral pressure of internal loads. So retaining walls is more like a wall beside a road or beside a passage, or even walls part of a building design to restrain soil to a slope that it would not naturally keep to. Lastly is the spandrel wall, the space between any arc and the beam over the same, or an exterior non-bearing wall in skeleton construction built between columns or piers and wholly supported at each story. Spandrel beams are load-bearing structural members around the perimeter of a floor of a building. Not only may they support loads from the roof and other roofs, they may also help support a building's walls. In this figure is an example of a column and CHP wall section detail of the points mentioned earlier. Next are curtain walls. Panel walls are exterior, non-load-bearing walls whose outer surface may or may not form the exterior facing of the building and whose interior surface may or may not form the interior finish. It may rest on the building structure or may be hung from the structure. Masonry panel walls are exterior, non-load-bearing walls whose outer surface may form exterior building face, or it may be used back of panel curtain wall as backup. The 2 types of masonry panel walls are the stone masonry panel and the precast masonry panel wall units. Stone masonry panels are natural or artificial stone slabs which are anchored to the building structure by masonry anchors. This is an example of a view of the building facade, its elevation, and its section details. These are also other details of the walls that includes connection details, soffit details at wall, vertical joint detail, and base detail.
What's up everyone, it's Aloha Ginobales and welcome to this part of vlog where I'm going to share to you the second type of masonry panel walls and the types of panel curtain walls. So let's have the second type of masonry panel wall, which is the precast masonry panel wall units. These are ordinary or prestressed concrete walls which may span from one floor or several floors. They are created through the mixture of water, cement, fine, and coarse aggregates. So let's proceed to the next topic, which is the panel curtain walls. These are exterior non-load bearing walls made up of panels attached directly to the building structure that can be adjusted and mounted. So there are types of panel curtain walls. The first type is the window type panel. The second is the skin type panel. The third is the sandwich type panel. And lastly is the wall units. So let's have the first type of the panel curtain wall, which is the window type panel. These are transparent glass and frame incorporated in the panel curtain wall. The second type is the skin type panel. These are panels made up of one material. The third one is the sandwich type panel. These are panel made up of assembly of several materials. So under the sandwich panel, there are two types of it. The first one is the open sandwich panel. So this is where the sandwich panel with top and bottom edges are closed. And the second type of the sandwich panel is the closed sandwich type, which means that sandwich panel and all edges of panel are closed except for weak holes and vents. And lastly is the wall unit. So this means that there are several panels in any type. Units may be one of the several stories. And moving on to the types of panel curtain walls. So the first type, which is the stick type. So this refers to the method of installation where the mullions and horizontal rails are installed first. The next type is the unit and mullion type. Similar to the stick system, mullion are the first tube to be installed in the unit and mullion system. The spandrel and glazing are inserted in order to complete the system. The third type is the grid type or the unit type. It is a division that is created horizontally or vertically on the wall. The next type is the panel or sheet type. This refers to the protective covering or casing that is applied on the walls. Another type is the spandrel type, wherein it is located between division areas of windows, which conceal structural columns, floor slabs, and shear walls.
We start the section 2D and I will discuss my part of this report. So, sheet type industrial support not express non-linear pattern joint vertical panel size with approx 4 high 60 max. Assembly method of panel curtain walls may be by individual panels. 2 wall unit with 6 max high 1 several stories. Pressure equalized design curtain walls. Pressure differential between the outside atmosphere and interior environment can cause rainwater migrate through even the smallest opening in wall joint. Pressure equalized design can significantly reduce the cause of water leakage in wall construction by employing the rain screen principle. Pressure equalized design in glass curtain walls. Creating horizontal rail. Deterrent seal. Isa sa opening. Pressure equalization chambers. Tie air cells or cell. Retaining walls, breeze walls, and bolt walls. A retaining wall is a wall whose purpose is to resist the thrust of the bamboo or other material. It is different from breeze wall, which is similar to the retaining wall. In the retaining the earth other piling and deposit behind it after it is built, while the breeze wall or piece wall is built to prevent the wall of earth which is in undisturbed lateral position but from which part has been excavated, turning vertical or inclined face. Retaining walls of three types. Gravity wall. This is a type of wall which contract of such a proportion weight alone resists the thrust of the earth. Low walls are variable gravity walls constructed of brick, stone, masonry, or concrete. Cantilever walls. The cantilever walls is constructed of the reinforced concrete and makes use of the weight of the earth in resisting the tendency to overturn the outer range. The vertical walls support on a horizontal base serve as the cantilever beam is resisting the earth pressure. Walls of intermediate high are generally of the cantilever type. Counterpart wall. It is similar to the cantilever wall with the exception the vertical walls is tied to the base of regular interval, which triangular shape was called counterpart. A counterpart is similar to the about trees, but where buttress is the place of the side of the wall, opposite the pressure acting on it. A counterpart is a place on the same side of the wall. It is usually more economical to use the counterpart wall for heights of 20 foot or over. In large cities, it is customary to utilize the space under the sidewalk for storage or the purposes. This disadvantage of a wall of the carb line is hold back the earth and the street pressure, also the weight of the sidewalk. There are called bolt walls, pre-stressed concrete. The concrete is the conventional reinforced concrete beam. It's not used economically with respect to bending stresses. Only the concrete have natural surface resist comprehensive stresses. All the concrete is the tension area below the neutral axis. It's distributed in a distinct way because the concrete is relatively weak at tension. Therefore, only about 1/3 of the concrete resists compression stresses. The maximum stress being the top of the beam, with the stresses decreasing in the magnitude to zero stress at the natural surface. Since the usually reinforced concrete beam, concrete cannot be used efficiently, certain force may be applied to the beams that result in a member in which all the concrete resist bending stresses. These are known as pre-stressed concrete. Pre-stressed concrete. A pre-stressed concrete beam is prepared so designed constructed that all the stresses in the concrete resulting from bending are comprehensive. That is the tensile. The name derived from the fact that stresses are applied before the beam is loaded. There are two methods pre-stressed concrete, namely pre-tensioning or bonded pre-stressing. In this method, the reinforcing steel is first pre-stressed and then the concrete is poured. When the concrete has developed strength, the stress is the steel in the release. The steel when straight out becomes smaller in cross section. Then when it's unstressed and the concrete hardened around the while they are still small, when their vertical tension is released after the concrete hardened, they expand, reverting to the original shape, grip surrounding concrete. The bond between concrete and steel is sufficient to create compression in the concrete. So there's Technora, stainless pipe, tensioning grid, mortar, post tension on unbonded pre-stressing. In this method, tube conduits of channel are inserted in the concrete where reinforcing steel is required. After the concrete is adequately cured, steel reinforcement is inserted in the tube and channel stretched to the proper tension. And approach on the end of put a squeeze on the beam. Tensioning is done with hydraulic jack. The reinforcing for pre-stressed concrete is usually wire, strand bar or rope made for heat-treated steel. Concrete must meet strength usually greater than AA type concrete which has a strength of 37.50 BC in 28 days.
Good day everyone, this is Chris Santias from Building Technology Group 3 and this is my virtual lecture. And firstly, the advantages of pre-stressed concrete. Number 1, it is economical of materials due to the use of higher steel and concrete stresses. Number 2, it eliminates cracks because the concrete is always in compression. Number 3, it has remarkable elastic properties. For example, tests were made on a floor slab only 1 to 5 over S8 inches thick, reinforced with not more than 1% steel. Although the span was only 10 feet, the slab deflected 3 inches under a load of 1,070 pounds at its center. When the load was removed, it returned to its original level undamaged. Beams do not have to be cast at the side in one form, but may be cast in small sections or blocks at the factory with reinforcing wires threaded through them. When wires are stressed, the small units are brought together like one large beams. The fifth one is it develops remarkable resistance to shear stresses. Pre-stressed concrete is used where spans and loads cannot be adequately designed in reinforced concrete, and for deckings, beams, girders, and other prefabricated units where greater spans and loads with thinner, stronger, and in some cases lighter members are required. The designing of pre-stressed concrete for structure is highly technical, and the architect should always be working with a structural engineer, even when using prefabricated pre-stressed concrete units. The precast concrete floor systems, from the word precast, these concrete floor systems are already fabricated from factories and is not on site. Precast concrete slabs, beams, and structural tees are one-way spanning units that may be supported by side-cast concrete, precast concrete, or masonry bearing walls, or by steel, side-cast concrete, or precast concrete frames. The precast units are manufactured with normal density or structural lightweight concrete and pre-stressed for greater structural efficiency, which results in less depth, reduced weight, and longer spans. The units are cast and steam cured in a plant off-site, transported to the construction site, and set in place as rigid components with cranes. The size and proportion of the units may be limited to the means of transportation. Fabrication in a factory environment enables the unit to have consistent quality of strength, durability, and finish, and eliminates the need for on-site formwork. The modular nature of the standard size units may not be suitable for irregular building shapes. So this is very good if you want a faster construction process, and it's not so good when you don't have the right or big transportation, because you can only transport concrete floor systems that is in according to the transportation that is going to be delivering them to the work site. And it's also not as good for irregular building shapes, but it is very good for normal construction process, and it's heavily used for its speed. These are the types of precast concrete floor units. The first one is the solid flat slabs, the hollow core slabs, the single T's, the double T's, the rectangular L-shape and inverted T-beams, and the AASHTO girders. The next one will be the building protection systems. These are categories of building protection systems. Number 1 is waterproofing. It's just very self-explanatory. A method of making buildings surface impervious to water. The next one will be the dam-proofing, applying a water impervious material or a vapor barrier to a surface, usually a slab on fill, to prevent the penetration of moisture from the ground or the exterior, or to prevent the penetration of condensate to the surface material. Example is the Barafilm vapor barrier. One layer at 6 mils, 0.006 thick with a 300 mm overlapping. So although you already have waterproofing, the ground can produce a lot of water vapors and it can actually condensate. And although you already have waterproofing, your structure will be damp from all the condensation. The next one is the water repelling or water sealing, which is very self-explanatory. Applying by brush or low pressure spray a clear silicone water repellent or sealant to porous surface materials such as cement, plaster, and bricks to prevent weathering or growth of algae and moss. Example is the Thompson's water seal. The fourth one is the thermal insulation, a method of installing thermal barriers in the surface of structures to keep the heat or cold away from the interior spaces. So depending on where your structure is and its environment, the interior either needs to be cold or letting heat. The next one will be the termite, or in Filipino dialect, anay proofing. The first method will be soil poisoning, treating the soil surrounding the structure in touch with the ground, footing bed and slab on fill with a chemical. example is Lentrec TC thermocyte concentrate, dilution rate of 1 part Lentrec TC to 50 parts water. Factory applied wood preservatives. Factory pressure applied wood preservatives such as Bolidin salts, Wallman preservatives or Selignum preservatives of Mantimco Wood Manila Timber Company. So this is basically just wood preservatives applied in the factory. The third one is the most used one. It's the site applied wood preservative. The application of chemical liquid on the wood surface, Selignum, to protect it against the pest intrusion, such as termites and powder post, beetles, or in Filipino dialect, pukpuk, and decay-causing fungi such as sap stain and rot. The next one will be the termite shields. Installing a shield of non-corroding metal or non-organic material used as protection against the infiltration of termites in a building, so placed as to prevent their passage, usually as a projection shield on a masonry foundation or a pier, or under a wood sill or a beam which it supports, or around pipes which enter the building. The next one will be the rat proofing. Very self-explanatory. A method of protecting rooms against the intrusion of rats and other small destructive animals from gnawing the wooden parts of the house and habitating under ceilings and under floors of houses and buildings. Last one is going to be fireproofing. Application of cover materials, structural steel components or system to provide increased fire resistance, also called spray fireproofing. An example of this is the flame shield fireproofing. Filipino invented non-asbestos fiber mix or non-organic binder, 1 inch thick for 2-hour fire rating, 2 inches thick for 3-hour fire rating, and 3 inches thick for 4-hour fire rating. Another example is the Monocote MK6 gypsum-based cementitious spray applied fireproofing product from Grace and Construction Products. You really need to fireproof your structure, especially if you're going to be using either wood or steel, just to prevent the spread of fire. And the last one, we're just going to be looking at the roof assemblies. The first one is the lightweight insulation concrete joists and beams. The next one is the insulation boards. These are the joists and beams. The next one is the protected floor assemblies. These are the beam and steel deck. And the last one will be the joist and steel deck. So that will be all for my virtual presentation. Thank you very much for listening.
Hi guys, this is Carl James T. Tinoy from Architecture 2D. So let's tackle about what really is a joist and beam. A beam is the main load-bearing structural element of a roof. It supports the weight of joist and other building elements. A joist is a horizontal member that generally runs across a building and is supported by a beam. 8. Floor protection. A method of protecting finished floor surfaces from wear and tear or from chemical abrasions due to heavy use. Next is the rust proofing, a method of protecting the steel and other ferrous materials from corrosion. Lastly, the discolors paint and chemical strippers, a method of removing old paint by the use of a paint remover and stains, rust, algae, or even cement buildup on forms or equipment by the use of a chemical stripper or discolor. The waterproofing. It is applied in the top of roof decks, top of concrete terraces, balconies, ledges, and canopies. Next is the undersheathing for wood shingle and tile roofing. Interior surfaces of water tanks, exterior surfaces of concrete roof gutters, inside surfaces of plant boxes, kitchen floor and toilets, basement floor and walls, elevator pits, swimming pools and fish ponds, machine, mechanical and pump rooms, refrigeration and cold storage rooms. 4 types of waterproofing. These are the integral type, membrane type, fluid type, and cementitious type. Integral type. Powder form waterproofing compound mixed with a cement aggregate mixture. For example, 1 bag of integral waterproofing compound such as Sahara or Sakura is added to 98 kilos of Portland cement. Next is the membrane type, a hot or cold membrane applied to the surface. For example, asphalt paper laid with hot asphalt or self-sealing asphalt paper. Examples from W.R. Grace Corporation are Bitutin CP for toilet slabs and Bitutin 3000 for roof decks, and ice and water shield, self-sealing and self-adhering rubberized membrane for main entrance canopies made of metal. Next is the fluid type, a fluid applied elastomeric coating formulated to waterproof and preserve the substrate of concrete, wood, and steel. The wide temperature range withstands extreme thermal movement, settling and cracking, resists puncture and tearing, and can be applied by ruler, brush, spray, or squeegee. Examples of exposed type liquid membrane waterproofing from WR Grace are NewFlex and NewFlex R100 for ledges. Lastly, the cementitious type powder form waterproofing compound mixed with water and applied by brush to the surface to be waterproof. Examples from the WR Grace are Mortasil and Hydradite for concrete gutters and ledges. Foundation and substructure waterproofing contains the bituthene mastic or liquid membrane, Hydroduct 220 drainage composite or Servipack protection board, bituthene membrane, bituthene mastic or liquid membrane, discharge pipe, geotextile wrapped around pipe, and hydrophilic water stop, liquid membrane corner detail. And of course the concrete wall, concrete footing, and the floor slab. Next is about the ground beam waterproofing. It consists of pre-proof 300R, pre-proof tape, structural concrete, and concrete blinding. And then the base slab pipe penetration waterproofing. It contains pre-proof tape, liquid membrane, hydrophilic water stop, optional, and concrete slab. And of course, the concrete blinding. And that's all. Thank
Base
you.
slab pipe penetration waterproofing is composed of hydrophilic water stop, which is optional, pre-proof tape, liquid membrane, pre-proof tape 300R, which is placed also in a concrete binding and in a concrete slab. A through wall penetration waterproofing, a pipe on a concrete wall with a line of temporary works. This includes pre-proof 160R membrane, liquid membrane, hydrophilic water stop, which is optional, pre-proof tape, hydroduct drainage composite, which is also optional. Flat deck waterproofing on concrete or masonry slab, upstand detail shear member, mesh reinforced rendering, bituthene membrane turned into 15 by 15 mm trays, which is optional, and painted with liquid membrane fillet, extruded polystyrene insulation finished podium level, bituthene membrane. Apply bituthene mastic or liquid membrane to all laps within 300 mm or 12 inches of corner. Hydroduct 650 drainage composite. In a typical drain detail in an outlet pipe, it consists of Hydroduct 650 drainage composite or Servipack protection board, pumping ring and behead of bituthene mastic or liquid membrane, goulet created by others, double entry goulet, bituthene membrane, creed to falls, bituthene sheet or liquid membrane reinforcing just over flange 150 mm in all directions. Next is a typical pipe detail through roof slab, liquid membrane detail. So in this detail, solar shield or metal flashing with clamping ring, liquid membrane, ground solid, finished roof ravel, Hydroduct 650 drainage, composite or Servipack protection board, bituthene membrane. Next is a typical pipe detail through roof slab, sheet membrane detail. So in this detail, solar shield or metal flashing, liquid membrane, waterproofing membrane. Lastly is the expansion joint cover deck or wall junction. Consists of liquid membrane over termination bar, 225 or 9 inches inverted strip of bituthene membrane, bituthene strip, pull with bituthene membrane, Hydroduct 650 drainage composite or Servipack protection board, liquid membrane, apply bituthene membrane to edge of expansion joint system by others, joint filler, and liquid membrane.
Now let's proceed to thermal insulations. Thermal insulations has application locations of heat insulators. These are top or bottom of roof decks, below roofing sheets, and above suspended ceiling. So these are the types of thermal insulators. We have the loose fill. These are fibrous type and granular type. Loose fill insulators consist of small particles formed from an insulation material that can conform to any space without disturbing structures or finishes. The next one is blanket insulation. Blanket insulation is made from fibrous materials such as mineral wool, wood fiber, cotton fiber, or animal hair and made into a band or boards. So blanket insulations also can be used as acoustical insulations for commercial buildings as well as thermal insulation for areas inside the home, appearing most often in attics. Next one, the block or rigid slab insulation. So these are the stiff and inelastic such as foam plastic, cellular glass, foamed concrete, etc. Rigid insulation provides thermal protection and it can also serve as an air moisture barrier. The next one is foam in place insulation. So a foam in place insulation are a polyurethane product made by combining a polyisocyanate and a polyester resin. The polyurethane is sprayed into the wall or ceiling cavity as well as liquid, and as the components mix, they instantly expand, foaming to create the insulation. And the last one is the sprayed-on insulation. Materials are used polyurethane from asbestos fiber mixed with inorganic binders. Sprayed-on insulator is a spray-applied plastic that is widely used to insulate buildings and seal cracks and gaps.
This has been Group 3. Thank you for your patience and God bless.